Today we're looking at velocity time graphs and finding displacement and acceleration from them. In this simple velocity time graph we can see it's horizontal, which shows that an object is moving with a constant velocity. So a horizontal graph doesn't mean that the object is stationary, it means its acceleration is zero. If we have a graph that has a positive gradient, it shows that the velocity of the object is increasing, that the acceleration is positive. Similarly, if we have a velocity time graph that is a negative gradient, the velocity of the object is decreasing. The acceleration is negative. Let's go through these questions. On a velocity time graph, displacement is found by finding the area underneath the line. The area for the first 6 seconds forms a trapezium. To find the area of the trapezium, we need the values for A, B and H. A and B are the parallel sides and H is the distance between them. So the parallel sides are 3 and 6 and H will be 12. Substitute that into our formula and we find the displacement is 40.5 meters. To find an acceleration on a velocity time graph, we just need to find the gradient of the line. So the gradient was found by dividing the change in y by the change in x. So for the first 3 seconds, y has changed by 12 and x has changed by 3. So 12 divided by 3 shows the acceleration will be 4 meters per second or 4 meters per second squared. On a velocity time graph, deceleration is found in the same way as acceleration with the gradient. The gradient for the final 3 seconds will be minus 12 over 3 because it's gone down 12 and the difference between 6 and 9 will be 3. So it's going to be minus 4. But we're asked for the deceleration. Deceleration is just the opposite of acceleration. So if the acceleration is minus 4 meters per second squared, deceleration will just be 4 meters per second squared. Let's finish with this. A ball rolls along a floor. Sketch the velocity time graph for the movement of the ball until stationary. If you think you know what that will look like, let me know in the comments below. And you can come to onmaths.com or click the link in the description to access all of our free A-level papers and predictions, and you can even save your scores with a free account. This video is part of a larger A-level course that you can follow along with at onmaths.com.